Hey guys, today we're going to do notes over central angles, arc lengths, and arc measures. We put this page on the Canvas. If you don't have your flip book, which most of my classes don't, I'm really sorry. So if you want to just either write this down on your own set of notes or print off this page and do it along with me. Okay, so today we're going to talk about central angles. A central angle has this it's an angle where the vertex is right here at the center of the circle. Let me change pens real quick. So this angle right here, angle ABC, is a central angle because its vertex is at the center of the circle. The sum of all central angles in a circle is always going to be 360 degrees because that's what the measure of a full circle is. All right, now we need to relate that to arc measure and arc length. The measure of an arc of a circle is equal to the central angle that creates that arc. So right here in this picture, this arc right here, AC, it will be the same measure as the angle ABC. So this angle, whatever its measure is, will be the same as that arc measure. There's a difference between arc measure and arc length. So one thing to think about, this will be in degrees. And this will have a measure like centimeters or feet or inches, something like that. It's an actual length measure. So just something to think about. So when you do the arc measure, it's going to be equal to the central angle. Arc length is like a fraction of the circle's circumference. And we talked about circumference last time. To get the fraction of the circle that you're talking about, you're going to do the angle measure divided by 360. That will tell you what the circle's, the fraction of the circle that you're talking about. And then you're multiplying that times the circumference of the circle. All right, let's just do some examples. I think that'll help us understand it better. Okay, I moved the paper up a little bit. All right, I'm going to fill in all of the angle measures on this circle before I start answering the questions. So remember things like you've got vertical angles are congruent. So this arc measure right here is telling me the arc measure is 43, which means that central angle right there is also 43. And then its vertical angle is also going to be 43. And so this arc measure will be 43. This angle is 79, so this arc measure is also 79 degrees. Then you need to think about things like the fact that this right here is a diameter. That's going to cut the circle in half, so that's going to be 180 degrees right there. So from here all the way to here is going to be 180 degrees. So to get that measure for angle, well, I don't know what that center of the circle is. To get the arc measure EF, I'm going to make sure I do 180 minus 43 minus 79. And that gives me 58. So this arc measure is 58 degrees, which makes this central angle also 58 degrees. Okay, so also on this side, we've got another 180 degrees. That's the other side of the circle, the other half. So we're going to do 180 minus 43 to get that other arc measure, which ends up coming up to 137. So this angle right here will be 137, and this arc measure is also 137. Okay, now we're able to answer some questions. So remember that it's really important how we name the arc. So we're asking you on this first one for arc EF because we only use two letters. That's the shortest distance between those two letters. So arc EF is this right here. And my answer is going to be 58 degrees. Okay, the measure of arc DH, that's going to be from D all the way to H. It's got to be the shortest distance because I only use two letters to name that. So it's got to be less than 180 degrees. And so that answer is going to be 137 degrees. The measure of arc GE, that's going to be starting here at G and going over here to E. Again, it's got to be the shortest distance between those two because I only named it using two letters. So the answer to that will be 79 plus 58, which is going to be 137. And if you'll notice, these two are the same, and that's because those are vertical angles, if you just kind of look at that in that picture. All right, the measure of arc HF. Let's see, this is getting so busy. And the measure of arc HF, this goes from here to here. Again, it's got to be the shortest distance between those two because you're only using 2 letters. So we're going to add 43 plus 79, and I get 122 for that. Okay, now we're changing it to where we're asking you for a bigger arc. We're asking you for arc EDG. You've got to go in order of those letters. It's going to be bigger than 180 degrees because we use 3 letters. That means it's a major arc rather than a minor arc. So let me see if I can erase some of this. I'm sorry, it gets really busy. Okay, so you're going to start, and I'll change pen colors too. Maybe that'll help. Okay, you're going to start here at E, and you're going to go through D all the way over here to G. We can't go the shortest distance between E and G because we use 3 letters, so we've got to go this way. So to get that answer, I'm going to do 43 plus 137 plus, what was that? Before I erased it, I'm sorry, another 43. All right, when you add those 3 together, you get 223 degrees. This was 43 before I erased stuff. Okay, now we're going to do major arc HDF. So, HDF, we're going to be adding 137 plus 43 plus 58, and that gives me 238. All right, so that's finding all the arc measures and really the central angles as well for that circle. Okay, so now I'm going to scroll down just a little bit, and we're going to work this other circle. Now, if you'll notice, this is the central angle right here, this 143. So this arc measure here is 143. The arc measure over here is 26. So you've got the arc measures for the full circle. And remember, a full circle adds up to be 360 degrees. So we're going to take 9x plus 5 plus 26 plus 7x minus 6 plus 143. And that's going to equal 360. All right, so adding all of that together or simplifying it by combining like terms, I get 16x plus 168 equals 360. And then moving the 168 over here, I get 16x equals 192. And so x will equal 12. And I've answered the question by finding the value of x. All right, on number 10, you've got all of the arc measures here. This one tells me this angle measure is 90 degrees. It's a central angle, so the arc measure is also 90. So again, I'll just set up an equation. I'm going to say 90 plus 4x plus 7x minus 12 plus 8x minus 3 equals 360. And then combining like terms, I get 19x plus 75 equals 360. I'm going to move the 75 over, so 19x equals 285. Divide by 19, I get x equals 15. All right, I have not answered the question. My question's asking me to find the measure of arc AD. Arc AD is right here. So I have to plug in that 15 to figure that out. So the measure of arc AD equals 8x minus 3. So I'm going to plug in 8 times 15 minus 3. That gives me 120 minus 3, which is 117. So my answer to this question is 117 degrees. All right, last example. I scrolled down a little bit again. Okay, we know some things like the fact that this is a diameter, so that cuts a circle in half. So I'm going to do 180 minus 55 minus 94 to figure out that this arc measure right there is 31, which is what they're asking me for right here. That's the arc measure. And we're needing to find the arc, the length of the arc, not the arc measure. But you do need to know that angle measure. So again, the central angle here is 31. Okay, to do arc length, you're going to take the angle divided by 360 times the circumference formula, because you're trying to figure out what fraction of the circle's circumference you're talking about. Okay, so our angle for arc RS is 31, so we're going to do 31 divided by 360 times 2 pi, and then our radius they told us was 9 meters. Okay, so you can, I've kind of run out of room, I'm sorry, I'm going to bring it on down here. You can get an exact answer. You can multiply all of your numerators together. You can multiply 31 times 2 times 9 and divide it by 360 and see what kind of simplified fraction you get. If you do that, you end up with 31 over 20 pi. That would be an exact answer. If you got a decimal for this value, it would end up being 1.55 pi. Or if you got a complete decimal, including the pi and everything, so you just multiply in your calculator 1.55 pi, you would get 4.869. And again, my units here are meters. We're going to make sure we include our units. So because on arc length, I want to make sure you remember that our units are something like meters or centimeters or inches rather than degrees. Okay, let's do the other one. We have arc STV. It's got to be, the arc measure has to be bigger than 180 degrees because you're using 3 letters. I'm going to go ahead and erase everything that we have here just to make it a little easier to see. Okay. So if we're talking about arc STV, it starts at S, goes through T, all the way over here to V. So I need to know this extra arc measure right there. I do see that this right here is a diameter, so it cuts a circle in half. So it should be 180 degrees on this side. So I'm going to do 180 minus 55 to figure out that the arc measure here is 125. So then when you add the 125, the 55, and the 94, I get that the measure of arc STV equals 274 degrees. Now I'm going to figure out the arc length. So I'm just going to abbreviate here. I hope that's okay. So arc length equals, we're going to do the arc measure, which is 274, divided by the full circle to see what fraction of the circle we're talking about, and then multiply that times the circumference. So 2 pi times our radius, which is 9. All right, if you were to simplify your fraction, you would multiply 274 times 2 times 9, and then you're going to divide that by 360, and so the simplified fraction, it's going to become 137 over 10, with a pi attached. If you got the decimal form of just that fraction, it would be 13.7 pi. And then if you were to go ahead and get the entire decimal value, it would be 43.04, and then meters. And that would be our answer. All right, that's our notes for central angles and arc lengths. Thanks.